Hello, hello, hello. Hello. Shall we start, ma? Shall we start? Okay, fine. See the first question. See the first question. A smooth sphere is moving on a horizontal surface with a velocity vector. Okay, we are having a smooth sphere is moving on a horizontal surface. Let us consider a horizontal surface which is smooth, and it is moving with a velocity that is 2 I cap plus 2 j cap. Immediately before it hits the vertical wall, this is my vertical wall. Okay, the wall is parallel to vector j cap. Coefficient of restitution between the sphere and wall is half. Between the sphere and wall is half. Okay, the velocity of sphere after it hits the wall. Let us consider this is the initial velocity of the sphere. We need to find velocity of the sphere after it hits the wall. Right? So, according to coefficient of restitution, it is V2 minus V1 by X2 minus X1. Right? So, final velocity of the sphere minus final velocity of the wall by initial velocity of the wall minus initial velocity of the sphere. Okay, either in x-axis or y-axis. Coefficient of restitution is 1. Coefficient of restitution is half. Okay, final velocity of the sphere, VSP bar, minus wall. Okay, along x-axis it is 0. Okay, initial velocity it is 0. Initial velocity of the sphere along x-axis it is 2. So we can say Vx sphere, it is minus I cap. Okay, na? Fine, na? Is it okay? Similarly, Vy, okay, Vy sphere minus final velocity of the wall, it will be 0. Initial velocity of the wall, that is j cap minus 2 j cap equal to 1 by 2. Right? Fine. After final velocity also, this is minus j cap. Okay, fine. So minus I cap plus 2 j cap. Vy bar of sphere will be 2 j cap. So it will be option 2. Right? Right. Fine. Next question. A resistor is constructed as a hollow cylinder with outer radii with inner radii as 0.5 centimeter and outer radii as 1 centimeter. And resistivity it is 3.5 into 10 power minus 5 ohm meter. Resistance of the configuration of length, it is 5 centimeter. We need to find resistance. Okay, na? Fine. Na? So, area we can write as pi times RB square minus pi times RA square. Area of the outer cylinder minus area of the inner cylinder. So, it is 3.14 into 1 minus 0.25 into 10 power minus 4. Convert into meter. So, area I can write as 1 minus 0.25 means 0.75. That is 0.75 pi into 10 power minus 4 meter square. Okay. Resistance R equal to rho L by A. Substitute values. Rho it is 3.5 into 10 power minus 5. Length it is 5 centimeters. Convert into meter. See here, resistivity is also in SI system by area 0.75 into 3.14 multiplied by 10 power minus 4. Okay. Upon calculation, we'll get as 7.42 into 10 power minus 3 ohm. Okay. They asked in terms of 10 power minus 3. So it is option A. Okay, na? Fine, na? Is it okay? Okay, na? Fine, na? Next one. Magnetic flux linked with stationary loop of resistance R is given as flux equal to A small t times capital T minus small t. The amount of heat generated in the loop. Heat generated means will indicate with H. Okay. Fine. Na? Okay. Heat generated, I can write it as I square RT or V square by T. Okay. So I'll write as E square by R into dt. Okay. They asked during a time interval. So 0 to capital T. Since E equal to minus d phi by dt. So minus d by dt of phi I can write as A small t into capital T minus A t square. Upon differentiation, we'll get as A capital T minus 2A small t. Right? So H is equal to E square A capital T minus 2A small t whole square by R into dt. Between the values 0 to capital T. Okay. Expand this one. So H equal to 1 by R times integral A square T square dt plus integral 4A square T square dt. minus 4a square capital T into T dt. Right? Between the values from 0 to capital T. 0 to capital T. Okay. So heat developed. Upon integration, we'll get as a square T square small t plus 4a square T cube by 3 minus 4a square capital T into T square by 2. Between value 0 to T, capital T. Apply the limits or final value and initial value. Okay, final value and initial value, which will get a square T cube by 3r. That is a square T cube. A square T cube by 3r. Okay. I think here 3 is there. 3 should be. Option D, 3 should be there. Okay, na? Write down. Fine, na? Next. Completed. Can I go to next question? Right. Can I go to next question? Okay, fine. Next, fourth one. Plates of a parallel plate capacitor having a potential difference V equal to 100 volt applied across them carry a surface charge density sigma equal to 15 nanocoulomb per meter square. Spacing between the plates is, okay, spacing between the plates means D. Okay, na? Nanocoulomb means it is 10 power minus 9. Right? Fine. So, since electric field between the plates, finite plates, it is E equal to sigma by epsilon. That is equal to V by D. Okay. So, D equal to epsilon naught V by sigma. Epsilon naught, it is having value 8.85 into 10 power minus 12. Potential difference, it is 100 volt. Right? By sigma, that means 50 into nanocoulomb means 10 power minus 9. Okay. So upon calculation, we'll get it as, okay, upon calculation, we'll get it as 1.77 into 10 power minus 6 meters. That is nothing but 1.77 micrometer. Upon calculation, we'll get it as, think, you can see here, 51s are 52s are, okay, 17.7 into 17.7 into 10 power minus 3. Okay, na? Fine, na? Okay, na? Is it fine? 50 into 10 power minus 9, 8.85, 8.85 into 10 means 17.7 into 10 power minus 3. Okay, into 10 power minus 3. They asked in terms of micrometers, right? So it will be 177 micrometer, right? Here they give Newton nanocoulomb per centimeter square by 10 power minus 4. So this is into 10 power minus 4, 10 power minus 16 by 10 power minus 7. Here it is. Okay, na? Fine, na? Okay, na? Completed. Okay, na? Fine, na? Next one. Fifth question. An artificial satellite is moving in a circular orbit around the Earth with a speed equal to half the magnitude of escape velocity. Okay. The height of the satellite above surface of Earth is. Okay. So we can say the speed it is under root capital G capital M by R plus H. Okay. Escape velocity formula it is under root 2G capital G capital M by R. Right? Capital G capital M by R. So under root capital G capital M by R plus H is equal to 1 by 2 times under root capital G capital M by R. Squaring on both sides will get capital G capital M by R plus H equal to 1 by 4 times capital G capital M by R. Upon calculation, we'll get R plus H equal to 4R. So H equal to 3R. Right? Fine. Is it okay? Okay, na? Completed. Next one. Eighth one. Is the eighth question. It is sixth one. An ideal Carnot engine works between, that is T1, temperature of source, it is 227 degrees Celsius. T2, it is 57 degrees Celsius. Always, while solving the questions on Carnot engine, we need to convert into Kelvin. We need to find efficiency. Efficiency of Carnot cycle, it is 1 minus T2 by T1. Okay. 227 convert into Kelvin, which will get it as 500 Kelvin. Okay. 273 plus 57 means approximately we'll get it as 330 Kelvin. Right? So it is 1 minus 330 by 500. That is eta equal to 170 by 500. Okay, na? So efficiency means eta equal to 170 by 500 into 100. 170 by 5 means, okay, approximately it is 34%. Okay, na? Is it fine? Okay, na? Fine, na? Next question it is, at the center of current carrying circular coil of radius is 5 centimeter. Magnetic field due to earth, it is 0.5 into 10 power minus 5 Weber per meter square, or we can write as Tesla. Okay, fine. Current flowing through the coil so that it equals to earth magnetic field. What is the current flowing through the coil when it is equal to the earth magnetic field? Right? So, at the center, we can say it is mu naught I by 2R. B equal to mu naught I by 2R, because they gave at the center of a current carrying coil, magnetic field due to the coil, right? So that it equals earth magnetic field. So I equal to 2RB by mu naught. Substitute the values. So 2 into 5 centimeter, 5 into 10 power minus 2 into 0.5 into 10 power minus 5 by 4 pi into 10 power minus 7. Okay. So upon calculation, we'll get as I is equal to 0.398 ampere. That is approximately 0.4 ampere. Right? You can see the calculations. Fine. 2 into 0.5 means 1. Okay. It is 5 by 5 divided by 4 pi. 4 into 3.14 means 12.56. Fine. Is it okay? Okay. Next one. 8th one. A gun of mass 10 kg fires 4 bullets per second. Okay. Mass it is 10 kg. Number of bullets per second, it is 4. Okay. Number of bullets per second, it is 4. Mass of each bullet. This is mass of gun. Mass of each bullet, it is 20 gram. Velocity of bullet when it leaves the gun, it is 300 meter per second. Force required to hold the gun while firing. We need to find the force required to hold it. Okay, na? So force means dP by dt for one bullet. For n number of bullets, we can write as n. So F equal to n by t into mv. Right? So n by t means it is 4. Okay. And mass of each bullet, it is 20 grams. So 20 by 1000 into velocity of bullet. We need to find force required to hold the gun. Right? Fine. So upon calculation, we'll get it as 24 Newton. Is it right? Okay, na? Is it fine? Okay, fine. Next one. Ninth question. A particle performs SHM with an amplitude equal to 5 meter. At x equal to 4 meter, magnitude of velocity and acceleration are equal. When x equal to 4 meter, velocity equal to acceleration. We need to find time period. Okay, fine. So we can say velocity means I can say omega times under root a square minus x square. Okay. Acceleration means we can write as okay minus omega square x. Right? So under root amplitude means 5. So 25 minus x square equal to minus omega times x means 4. Right? Okay. They gave x equal to 4. So 25 minus 16 equal to minus 4 omega. Okay. So 25 minus 16, 9. Under root 9, we can write as plus or minus 3. Omega equal to what? 3 by 4. Right? That is nothing but 2 pi by t. So time period equal to 8 pi by 3 seconds. So it is option C. Okay, na? Is it fine? Right? Okay, na? Fine. Next, 10th question. See the 10th one. In an electromagnetic wave, the maximum value of electric field, okay, electric field it is 100 volt per meter. Average intensity, okay. Generally, we can write as intensity, I can write it as energy density times speed of light, right? Otherwise, intensity equal to energy per unit area and per unit time. Multiply and divide by displacement. Okay. Displacement by time is it is speed. Area into displacement means volume. Right? Energy by volume, I can write as energy density. Fine. Is it okay? So, since it is intensity, it is half epsilon naught E square into C. So, average intensity is half. Epsilon naught means 8.85 into 10 power minus 12. E square means 10 power 4. C means 3 into 10 power 8. Okay, na? Fine, na? So upon calculation, we'll get it as 13.2 watt per meter square. That is option A. Fine. Calculations after this class you do, ma. You see once. Okay. If anything doesn't match, you can send me. I'll explain. Fine. Completed. Or next. 11th question. A point object is moving with a speed v in front of arrangement of two mirrors as shown in the diagram. Magnitude of velocity of image in mirror 1 in this mirror M1 with respect to image in mirror M2. Okay. Okay. So firstly, in mirror M2, whatever the object is moving will have velocity of image is also same. Right? Okay. Like this. Like this, it is, we are having the velocity of the object. Along in the same direction, we'll have, okay, along in the same direction, we are having, okay, now. So, along x-axis or along y-axis, angle between velocity of image of 1 and 2, you can see, okay, we are having that it is this one and it is like this. Okay, na? So that means this is velocity of image 1 and this is image 2. Whenever the light rays are incident like this, it will move. It will be reflected back. Okay. Similarly, here also same. Whenever the light ray is incident, it will be reflected back. So that total angle will be 2 theta. Angle between the two images. So I'll use the formula V relative equal to under root V1 square plus V2 square minus 2 V1 V2 cos theta. Right? So it is for both images moves with the same velocity. Minus 2v square. Angle between the two images it is 2 theta. So under root 2v square times 1 minus cos 2 theta. Okay. 1 minus cos 2 theta means I can write it as 2 sin square theta. 2v square times 2 sin square theta. That is nothing but 2v sin theta. Right? That is option A. Fine. Okay. Completed. Is it over? Next, 12th one. A merry-go-round is at rest, pivoted on a frictionless axis. A child of mass m runs along the path, okay, like in a disc. Merry-go-round means like in the form of a disc. okay, tangential to the ring with a speed v and jumps onto merry-go-round. The radius of merry-go-round it is r. I is the moment of inertia. Then velocity of merry-go-round around the child is, right? That means angular momentum will be conserved. Initial angular momentum equal to final angular momentum. Initially, okay, initially child of mass m is moving along tangential. So angular momentum of the girl equal to angular momentum of the girl and plus angular momentum of the merry-go-round, right? Fine. So MVR equal to total system. This merry-go-round is having a moment of inertia I and girl is rotating with a radius r, right? So omega equal to MVR by I plus MR square. That is option A, right? Is it fine? Okay, na? Is it okay? Okay, na? Completed all of your okay. Next one. Amplitude modulation is the process of. Actually, this topic it is deleted, ma. This will comes in the communication system. Modulation is the phenomena of superposing a low frequency information with high frequency, with a high frequency. Okay. So superposing a low frequency signal on a high frequency signal can be called as modulation. Can be called as modulation. Okay, na? Fine, na? Okay. Fine, na? Okay. Next one. 14th one. 14th one. You can see. See the 14th next question. It is, if temperature is raised by 1 Kelvin from 300 Kelvin, initial temperature it is 300 Kelvin. Final temperature it is 301 Kelvin. The percentage change in speed of sound in the gaseous mixtures. Okay. Percentage change in speed of sound. Suppose if V is the speed of sound, then we need to find delta V by V into 100. Okay. Speed of sound, we are having the formula under root gamma RT by capital M. Gamma capital R by M, it is a constant. So velocity is proportional to root T. Okay. So delta V by V equal to 1 by 2 times delta t by t. Okay. So delta v by v equal to half into 1 by 300. So delta v by v into 100 equal to 1 by 6%. 1 by 6 means we can say 0.167%. Right? Fine. Is it okay? Okay, na? Fine. Na? Is it okay? Okay, fine. Next one. Next question. In a reverse bias diode, when applied voltage changes by 1 volt, okay, the current is found to change by 0.5 microampere. Reverse bias resistance. Resistance R equal to delta V by delta I. Can I write? That is 1 by 0.5 into 10 power minus 6. 1 by 0.5 into 10 power minus 6 means I can write 2 into 10 power 6 ohm. Right? That is option B. That is option B. Fine. Write down. Next, see the 16. Once see the question. Okay, na? Anyone got idea how to solve this 16th question? Hmm? Mortaja, a rod of mass capital M and length 2L and length 2L. Okay. Is suspended at its midpoint. Suspended at its middle by a wire. It exhibits torsional oscillations. If two masses each of mass small m are attached at a distance L by 2 from the center on both sides, it reduces oscillation frequency by 20%. Okay. Oscillation frequency, it is reduced by 20% means, suppose initial frequency F will consider and F2 it is reduced by 20%, right? So it will be 80% of F is remaining. That is nothing but 0.8 F reduces the frequency by 20%. Okay. Fine. Na? Okay. Na? Is it okay? Okay. Generally, time period of oscillations, it is torsional pendulum, it is 2 pi into under root I by C. So frequency will be 1 by 2 pi into under root C by I. First, it is rod is suspended at middle of the wire. We are having a rod. It is suspended by a wire like this. Okay, two masses each of mass m are attached at distance L by 2. Okay, here I'm having mass m and here I'm having another mass m. Right? Fine. At a distance L by 2 from its center on both sides. Now we need to find the ratio of small m by capital M. Okay, na? Fine. So initially F I can write as 1 by 2 pi into under root C by. It is a rod suspended from the middle. So I can write ml square by 12. Here length it is 2L. So m by 12 into 2L whole square. Plus particles, two particles are there at a distance L by 2. So 2 into ml square by 4. Right? Now, new frequency, that is frequency is reduced by 20%, reduces by 20%. Right? So, it is 0.8 f equal to 1 by 2 pi into under root C by both the rod and two particles are at edge m by 3 into L square. Suppose this is first equation and it is second equation. Upon solving, we'll get the ratio small m by capital M equal to 0.37. 0.37. Right? See, first equation it is 1 by 2 pi into under root C by capital M into 2L whole square by 12 plus 2 into small m L square by 4 because both the particles are at a distance L by 2. Okay. Fine. Okay, fine. Is it completed? Okay, na? Can I go to next question? Can I go to next question? Okay, fine. Next 17. 2 full turns of a circular scale screw gauge cover a distance of 1 mm. Okay, on its main scale. Total number of divisions on circular scale it is 50. Okay, screw gauge is having a zero error of minus 0.03. Okay, so error is negative. Value added to be, it is positive. To make into zero error, value added. Okay. While measuring the diameter of a wire, the main scale reading is 3 mm. And number of circular scale divisions in line, it is 35. Okay. So, total scale reading, pitch scale reading, okay, total pitch scale reading, okay, plus head scale reading into least count, okay, plus or minus error. This is the formula. Pitch scale reading they gave as 3 mm. Head scale it is 35 into least count. Okay, zero error they gave it as 0.03 mm. All are in mm only. We need to find least count. Least count it is value of one pitch scale division, that is 1 mm, by number of circular scale divisions, that is 50. Right? Fine. Number of this one. So 3 mm, 2 full turns. 2 full turns they give. So it is 0.5. So it is 0.5 by 50 means 0.01 mm. So total scale reading will be 3 mm plus 35 into 0.01 mm minus 0.03 mm. So it will be, okay, since it is, error is negative, value added to be positive. So 3 plus 0.35 plus 0.03. So 3 plus 0.38, that is nothing but 3.38 mm. That is first option. Right? 3.38 mm. Right? Fine. Over. Completed. Next, 18th one. An infinite wire places along z-axis has current I1 in positive z direction. A conducting rod placed in xy plane parallel to y-axis has current I2 in positive y direction. Okay. The ends of rods subtend angles 30 degrees and minus 60 degrees. 30 degrees and minus 60 degrees. Okay. That is, suppose we are having one wire. It is at an angle 30 degrees and another wire, it is this angle minus 60 degrees. Okay. A current is flowing. Current I is flowing in the wire. Okay. So that here it is, we can write as coordinates as a comma root 3a, and the bottom it is a comma minus root 3a. Okay, na? Fine. Okay. We need to find the rod is at a distance a. What is the net force on the rod? Okay. Force means, let us consider dF bar equal to, okay, BIL sin theta, okay, I times L bar cross B bar. Okay. So current it is J cap. Magnetic field it is along minus I cap. Okay. L J cap cross B times minus I cap. Okay. Fine. I cap cross J cap means K cap. So it is minus BIL times minus K cap. Okay. Fine. So force equal to mu naught by 4 pi into 2I1 I2 times integral tan theta d theta, right? Between values from minus 30 degrees to 60 degrees. Upon calculation, we'll get it as mu naught by 4 pi 2I1 I2. Okay. Integral tan x dx means we can write as log module cos theta. Okay. Log cos theta between values minus 30 degrees to 60 degrees times minus K cap. So it is, upon calculation, we'll get mu naught by 4 pi 2I1 I2. Okay. Log cos 60. That is log 1 by 2 minus log root 3 by 2. Right? Log root 3 and minus root 3. Okay, na? Fine. Upon calculation, we'll get force equal to mu naught by 4 pi I1 I2 into ln 3 times minus K cap. That is option A. Okay, na? Fine. Write down. Okay. Next one. The graph shows how the magnification produced by a thin lens varies with distance. Focal length of used. Focal length we need to find. Okay. In generally, magnification of a thin lens, it is, we can write as 1 minus modulus of V by F. From the graph, slope will be 1 by F. Okay. Slope will be 1 by F. So, slope it is, you can see here it is. P by B equal to 1 by F. So, F equal to B by C. That is option A. Okay, na? Fine, na? Next, 20. 2 points on traveling wave have a frequency 500 hertz. Velocity it is 300 meter per second. Are 60 degrees out of phase. Minimum distance between the 2 points. Okay. First, V equal to n lambda. Lambda equal to V by n. That is 300 by 500. That is nothing but 3 by 5 meter. Phase difference is 60 degrees. 60 degrees means I can write 5 by 3. Since phase difference equal to 2 pi by lambda times path difference, that is nothing but d. So pi by 3 equal to 2 pi by 3 by 5 into d. So the distance it is pi by 3 equal to 10 pi by 3 into d. Right? So pi by 3 will get cancelled. D equal to 1 by 10 meter. That is nothing but 0.1 meter. Right? Fine. Okay, na? Is it fine? Okay. Remaining, those who want paper now, once you message me, remaining questions try. If you didn't get asked, okay, I will discuss. Okay, na? These 5 questions you can see. Fine, na? Okay, we'll meet in another session. Okay, fine, na?